Then I'll drag with a constant velocity V. So at time t, I'm asking all these conditions. What is the current in the circuit? What force I should apply on the rod PQ, and what is the power generated by external agent? And what is lambda? Lambda is resistance per unit length. So now you go for different shaped loops. It was only rectangular, no? Now we have some sort of like a triangle, and what happens to area? Area increases. First, let's go for Faraday's law. When EMF will be induced, when flux linking the loop changes, B bar is constant. Area is varying, no? Area is going to increase. Area of that triangle is going to increase. Area of the triangle is going to increase. The flux is varying. So EMF will be induced. Due to that, induced current will flow. So let's how to calculate all these things. So this moving rod will behave like a cell. As still the idea is same, but calculation of flux is something very important in this case now. So this P rod PQ is there, no? So let me take this is P1. I'll call P1 as Q1. The point P1 and Q1 of the rod are in contact with the rods AB and with AB and BC. Let me do one thing. So let me take this is X. This distance, let it be X. What is V equal to? Dx by dt, I can write it now. The first assumption, V equal to dx by dt. I know X. This is 90 degrees. So this angle should be how much? 45 degrees. So what should be the, and this should also be 45 degrees. So call this is O. So P1O and Q1O, they must be equal. And it should also be equal to X. And what is X in turn? X should be equal to Vt, no? Because it is moved with a constant velocity. So V is a constant. Direction is maintained constant and magnitude is maintained constant. So constant velocity is telling. So therefore, what is X should be equal to Vt. So I'm able to define the overall, the length of the perimeter of the rod. What is P1, B, Q1? So let's calculate the flux linking the loop. Flux linking the loop should be equal to B into perimeter of the loop. Or area, I should take it. I think I should take area, no? Area of triangle. Area of triangle P1, B, Q1. What should be the area? Half into base BQ1, height BP1. What should be the BQ1? Root X. So the X root 2. This. Yeah. Then what is BP1? This should be X root 2. Because OQ1 is equal to X, no? This is, so finally this will be Bx square, I'll get it. This is the flux linking. And what is in turn X is equal to, X should be equal to Vt. Flux should be equal to B Vt whole square or Bv square T square. Now I have flux. I'll differentiate this. Differentiation, this one, d phi by dt. Only magnitude I'm predicting. So this will be 2b v square t. Can we predict direction of current? Go back to
it will be bx square by 2, sir. Flux bx square by 2.
Root 2.
Okay.
Now there's the EMF induced. So from Faraday's law, what should be the direction of induced current? Negative flux increases defined negative, EMF induced positive. So the induced current, in fact, should flow like this. At any instant of time, this is induced current. So now I know E. Can we predict R, the induced current I? So what should be I is equal to E by total resistance of circuit of the loop. What is the 2b v square t? What is the resistance? Lambda is the resistance per unit length. No? So lambda into so perimeter of the loop. It's a very popular problem where student must different shaped loops will come. So and you should manage that one. So perimeter is what? BQ1 BP1 plus P1 Q1. I think what should be the values? BQ1 should be equal to root x. Already we have, or say x root 2. BP1 BQ1 also x root 2, and this should be equal to how much? 2x. Length P1 Q1, how much it should be equal to? 2x. I'll show total problem. It will be easier for you. Try to see now. I think everything is visible. So after solve,
it is root 2x, sir.
which one ma?
P1 Q1.
P1 Q1 is what? X plus x I'm writing it. No? P10 plus Q10.
Okay, sir. Okay, sorry, sir.
Okay, ma. Yeah. This should be x. X will come out, so this will be 2 root 2 plus 2. So lambda. And what is x? X in turn you are going to write Vt. To also get eliminated. Let's see that. Okay, we have only this much. Constant current flows. By looking at diagram, no, we feel something will end up with very big mathematics. A constant I current. So constant. So once you know current constant, things are all are easier. No, tell me what should be the expression for current. And then what should be the force I should apply? The external force I should apply on the rod should be equal to Bi into P1 Q1 B. P1 Q1 should be equal to 2x. So B square V, 2x is Vt. So this is the value of 2b square V square T by lambda into root 2 plus 1. So this much of external force I should apply. What about power? F external into V. So getting this method now, so different shaped loops will be coming for you. Like a parabolic shaped rod PQ. Here I took this one, no? It's like a straight rod I took it, some curve, some parabolic. So different shaped rods now will be moving. Now we have to calculate the flux linking the loop. Then as usual, so we have to proceed. So don't bother the negative sign. Direction of induced current, take help of directly Lenz's law. Focus on only the magnitude by using Faraday's law. This is the one easiest method to avoid that negative signs. Because in the mathematics, no, the sign here and there will trouble you. So what I suggest, get magnitude by Faraday's law, direction by the Lenz's law. You know that negative flux increases, d phi by dt negative, EMF induced will be positive.